So good morning, students. My name is Antonio Arias III and I am your teacher for this semester. So today our topic is all about function. What is function? But before that, we will have first our learning outcomes. At the end of the lesson, the learner is able to represent real-life situation using function, including the piecewise function. Lesson 1. Definition. A relation is a rule that relates values from a set of values called the domain to a second set of values called the range. When we say relation, it has a rule that relates from a values called the range and a second called the domain, and the second is the range. Or in short, it is in a set of pairs x and y. Definition. A function is a relation where each element in the domain is related to only one value in the range by some rule. Okay, so when we say a function, note that the function can be a relation if its element is related to only one value in the range. A function is a set of ordered pairs xy such that two ordered pairs xy such that no two paired pairs have the same x value but different y value. Note that a function is a relation if no two paired pairs have the same x value. Say for example, we have the set of numbers is 2 and 3 and 4 and 9. So to the first set, the x is equal to 2, and to the second set, the x is equal to 4. So we can say that it is a function because the value of x doesn't repeat to the other. Okay. Using a functional notation, we can write f of x is equal to y, read as f of x is equal to y. In particular, if a set of numbers 1 and 2 is an ordered pair associated with the function f, then we say f of 2, since the value of x is 1, so we can say that f of 1 is equal to ry, which is 1. When we say in ordered pairs associated with a function, then we say f of 1 is equal to 2. Example, which of the following relations are function? We have f is equal to, the ordered pairs are, we have 1, 2, 2, 3, 3, 5, 4, 7. Second, we have 1, 3, 1, 4, 2, 5, 2, 6, and 3, 7. And lastly, we have 1, 3, 2, 6, 3, 9, and 3 and ... So the relation of f and h are function because no two ordered pairs have the same value of x but different value of y, or the y value. Meanwhile, g is not a function because one ordered pair 1, 3 and 1, 4 are ordered pairs with the same x value but different y value. So note that the x value should not be repeated so that it can be considered as a function. Relation and function can be represented by the mapping diagrams where the elements of the domain are mapped to the elements of the range using arrows. In this case, the relation or function is represented by the set of all the connections represented by the arrows. So, relation and function can be represented by a mapping diagrams, and I will show you on how to identify a function to the mapping diagrams, where you can see in the mapping diagrams it contains the domain and also the range. Okay, so example number 2. Which of the following mapping diagrams represents a function? So first we have f, next is g, and next is a. So solution. The relation f and g are functions because each value y in y are unique for a specific value of x. The relation h is not a function because there is at least one element in x for which there is more than one corresponding y value. So as you can see here, f and g are functions because the value of x doesn't repeat to a set of ordered pairs, while h is not a function because the value of x repeats to another set of ordered pairs. For example, x is equal to 7 corresponds to y is equal to 11 or 13. Similarly, the value of x is equal to 2 corresponds to both y is equal to 17 or 19. So, a relation between two sets of numbers can be illustrated by a graph in the Cartesian plane, and that function passes the vertical line test. Okay, so as I told you earlier that you can also identify the graphs that are functions. So, say for example number 3, which of the following can be graphs or a functions? So, it is obvious that you can only identify the graphs if it is function is when a relation of two sets of numbers can be illustrated by a graph in the Cartesian plane, and that a function passes the vertical line test. So you can say that it is a function when the line passes the vertical line test, or the graph passes the vertical lines test. So as you can see here, A passes to a vertical line test, so it can be considered as function. For the letter B, B is also a function because it passes to a vertical lines test, while C is also a function because it passes to a vertical line test, while D and E are not because they do not pass the vertical line test. Okay, so that is the solutions. A, B, C are graphs of a function, while D and E are not because they do not pass the vertical line test. Try this out. So you will be given an answer sheets and you will solve this following problem and show your solution. So for the number 1, which of the following relations are function for 1 to 10? And another is you need to explain this. Explain is the relations, the ordered pairs are 0, 0, 1, 1, 2, 4, 3, 9, dot, 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 n to n square a function. Okay, so you will explain this. Then lastly, you are going to identify or which of the following mapping diagrams represents a relation that is not a function, and then you will explain your answer. Since we are done with that. Okay, tell whether the following graphs is a function or not. So you'll identify if the graph is a function or not. Next, function as a representation of a real-life situation. Function can be often used to a model situation. Identifying an appropriate functional model will lead to a better understanding of a various phenomena. So say for example number 1, give a function C that can represent the cost of buying X meals if one meal costs 40 pesos rather. So for the solution, since each meal costs 40 pesos, okay, so if one meal costs 40 pesos now, then when the cost function is function C of X is equal to 40x. Since the cost of one meal is 40, then you will multiply if you will buy another set of meals. Okay, are we clear? If you have questions, just ask me and I will answer it after our discussions. Okay, example number 2. 100 meters of fencing is available to enclose a rectangular area next to a river. See figure. So as you can see here, there is a figure there. So as you can see, there is a river. Give function a that can represent the area that can be enclosed in terms of x. So for the solution, the area of the rectangular enclosure is, this is the formula, we have a is equal to x to y. We will write this as a function of x. Since only 100 centimeter of fencing is available, then we can say that x plus 2y is equal to 100 because 100 is our 100 centimeter of fencing available. Or we can say y is equal to 100 minus x over 2 is equal to 100 divided by 2 is equal to 50. Then negative 1x divided by 2 is equal to negative 0.5. After that, multiply x to 50 minus 0.5x, and it will give us the answer of x times 50 is equal to 50x. X times negative 0.5x is equal to negative 0.5x squared. So that is the answer. Okay, how about if we change the number? How about if we change the number of the rectangle? How about if we change the number of the fencing? So you only change the number, but you cannot change its formula. So you can always use x plus 2y. Okay, next. Try this out since we are done with our discussions about the function as representation of real life situations. So now it is your turn to answer this problem. We will answer this in a given sheets. Piecewise function. Some situation can only be described by more than one formula depending on the values of the independent variable. Example number 1. User charged 300 monthly for a particular mobile plan which includes 100 free text messages. So in a month, the user pays 300. That includes 100 free text messages. Messages in excess of 100 each are charged 1 each represent the monthly cost for text messaging using the function T of m, where m is the number of messages in a month. So, solution. The cost of text messaging can be expressed by the piecewise function. So, let function T of m represents the amount paid by the customer each month. It can be expressed the piecewise function. Function T of m is equal to 300 if m is greater than 0 but less than or equal to 100. 300 plus the excess or m if m is greater than 100. Next, example 2. A jeepney ride's cost of 8 for the first 4 kilometers, and each additional integer's kilometers adds 150 to the fare. I repeat, the cost of a jeepney ride is 8 pesos for the first 4 kilometers, and if it exists in additional integers kilometers, it adds into 1.50 pesos to the fare. Use the piecewise function to represent the jeepney fare in terms of distance or d in kilometers. So the solution's value is the distance and the output are the cost of the jeepney fare. If function fd represents the fare as a function of distance, the function can be represented as follow. So, f of d is equal to 8 since it is the number, it is the cost of a jeepney ride. If d is greater than 0 and d is less than or equal to 4. Next, if d is greater than 4, so the amount to be paid is 8 plus 1.5 times the d, or the additional integer kilometers times the distance in kilometers. Okay. Next, evaluating a functions. So our learning outcomes, we have at the end of the lesson, the students are able to evaluate functions, solve problem involving function. Evaluating a function means replacing the variable in the function in this case x, with a value from the function's domain, and computing for the result to denote that we are evaluating f at a for some in the domain of f, we write f of a. So, for you to understand more about evaluating a function, so we will have our example. Okay, so evaluate the following equation at x is equal to 1.5. So, the value of x is equal to 1.5, and we will evaluate the following functions at x is equal to 1.5. A is equal to f of x is equal to 2x plus 5. Change the value of x, so it will become 2 times 1.5 plus 1 is equal to 4. Since 2 times 1.5 is equal to 3 plus 1 is equal to 4. Letter B, q of x is equal to x squared minus 2x plus 2. Change the value of x into 1.5, so it will become q of 1.5 is equal to 1.5 with the exponent of 2 minus 2 times 1.5 plus 2 is equal to 135 times 1.5 is equal to 2.25. 2 times 1, 2 times 1.5 is equal to 3, so minus 3 plus 3 is equal to 1.25. Okay, next we have g of x, so it will become 1.5, so is equal to square root of x plus 1, change x into 1.5, so the square root of 1.5 plus 1 is equal to square root of 2.5. Next, we have dr of x, or it is equal to 1.5, then 2x plus 1 over x minus 1, change the value of x into 1.5, then it will become 2 times 1.5 plus 1 over 1.5 minus 1. So it will become 2.2 times 1.5 is equal to 3 plus 1 over 1.5 minus 1 is equal to 0.5. Or 4 divided by 0.5, it will give us the answer of 8. Last, we have f of x is equal to absolute value of x plus 1, where x is the greatest integer of function. Okay, so substitute the absolute value of x is equal to 1.5. So the absolute value of 1.5 it is equal to 1. It is because one of the number is odd. And then add it plus 1 is equal to 2. So thank you. Next, example. Find the g of negative 4 and r of 1, where g and r are defined in the previous example. Solution. This is not possible because negative 4 is not in the domain of g of x, and 1 is not in the domain of r of x. So when you try to substitute negative 4 to g of x, the result is undefined, and if you substitute 1 to r of x, then the result is also undefined. So this is not possible because negative 4 is not in the domain of g of x, and 1 is not in the domain of r of x. So it is undefined. Okay, example 3. Evaluate the following function where f and q are defined in example 1. F of x is 3x minus 1, and b, we have q, our x is 3x plus 3. Solution. To evaluate f 3x minus 1, replace all the value of x in f of x is equal to 2x plus 1 by 3x minus 1. So it will become, f of x, it will become 3x minus 1 is equal to 2 times 3x minus 1 plus 1. So it will become 2 times 3x is equal to 6x, while 2 times negative 1 is equal to negative 2 plus 1. So 6x, negative 2 plus 1 is equal to negative 1. To evaluate q, 3x plus 3, replace all the x in q, x is equal to x squared minus 2x plus 2 with 2x plus 3. It will become q of x, which is 2x plus 3, is equal to 2x plus 3 with the exponent of 2 minus 2 times close and open 36. 2x plus 3 plus 2 is equal to, we have 4x squared plus 12x plus 9 minus 4x minus 6 plus 2 is equal to 4x squared plus 8x plus 5. Solve the following problem, show your solutions, use extra sheets of paper if needed. since we are done with our topic about about we are done with our topic about the piecewise function. Now, it is your turn to solve the problem regarding a piecewise function. Note that you will show your solution and you will use extra sheets of paper if needed. So, there are okay, another problems is you're going to evaluate the following functions at 3 at x is equal to 3 and show your solutions. Since we are done with our discussion about on how to evaluate a function. Okay, thank you. So, we will have our continuation of our discussion for this morning. So, our topic is all about operations and functions. So, but before anything else, our learning outcomes we have at the end of the lessons, learners is able to perform addition, subtraction, multiplication, composition of functions, and solve problem involving function. Okay, addition and subtraction. Okay, so these are the steps in solving addition and subtraction of a function. Okay, find the least common denominator in both fractions. Write the fractions as equivalent fraction with the same LCD. The LCD is the denominator of the numerators is the numerator of the resulting fraction. And lastly, we have the sum of the difference of the numerator is the numerator of the resulting fractions. Okay, for you to understand more about addition and subtraction of a function is we have here our example. So example number 1, find the sum of 1/3 and 2/5. Solution. The LCD of the two fraction is 15. So we have 1/5 plus 2 over 5 is equal to 5 times 1 is equal to 5 over 15 plus 3 times 2 is equal to 6 over 15. It is equal to 5 plus 6 is equal to 11. Then copy the denominator, which is 15. So next, find the sum of 1 over x minus 3 and 2 over x minus 5. The LCD of the two rational expression is, we have x minus 3 times x minus 5, or it is equal to x squared minus 8x plus 15. So the question is, where did we get our denominator? So simply, you just multiply x minus 3 times x minus 5 using the FOIL method, so that it will give us the answer of x squared minus 8x plus 15. So now the denominator is x squared minus 8x plus 15. So x minus 5 times 1, just cross multiply. X minus 5 times 1 is equal to x minus 5. Copy the denominator, which is x squared plus minus 8x plus 15. Then next is 2 times x minus 3 over the denominator, which is x squared minus 8x plus 15. So it is equal to, copy x minus 5, multiply. 2 times x is equal to 2x. 2 times negative 3 is equal to negative 6 over x squared minus 8x plus 15. So combine like terms. So since x and 2x are the same variables, so you can combine the two variables. So 1 plus 2, then copy the variable, which is x. So it will become 3x negative 5 minus 6. Since they are the same, so they have no variable, so you can combine it. Since they are the same in sign, so we will add the numbers and then copy the sign. So that makes it 3x minus 11 over x squared minus 8x plus 15. Okay, this is the steps in solving multiplication in a function. So we have here the steps. So first is the steps is we have to rewrite the numerator and the denominator. Example number 1. Find the product of 10 over 21 and 15 over 8. Express the numerator and denominators of the two fractions into prime factors. Multiply and cancel out the factors in the numerator and the denominator to reduce the final answer to the lowest term. Say for example, 10 over 21 times 15 over 8, or the factor of 10 is, it can be 2 times 5, while the factor of 21 is 3 times 7, and the factor of 8 it can be 2 times 2 times 2, it is equal to 8, and the factor of 15 is equal to 3 times 5. After that, cancel the numerator that is the same to the denominator. So, 3 cancelled, 2 cancelled, and after that, multiply the remaining numerator and at the same time the denominator. So, multiply 5 times 5 is equal to 25. Then, the denominator is 7 times 2 times 2 is equal to 28. Okay, so for you to understand more about our discussion about uh, operation of functions, um, you will answer this in a given sheet of paper. Show your solution. And if you have questions about our discussions for this afternoon, you can visit to our site, which is https://www.gaitf.com/elearning, or you can contact me to my number 0979 480 422. Okay, so thank you and God bless.